Good day everyone! I'm Kylla Ara Lingon, future educator in the making, and at this dunk tour, I'm going to discuss about the Earth atmosphere and the different layers it consists. I love watching the clouds above, especially when the weather is clear. Clouds with different forms and shapes, together with the blinding sun. Try to look up. The clouds you see in the sky, the wind that moves the trees, or your hair. Those are the result of the Earth's atmosphere. Atmosphere is the thin layer of air that surrounds the Earth. It is made up of various gases such as oxygen, nitrogen, carbon dioxide, dust particles, and water vapor. The gravitational force of the Earth holds the atmosphere around it. It protects us from harmful rays and scorching heat of the sun. The changes in atmosphere produce changes in the weather and climate. While oxygen is necessary for most life on Earth, the majority of Earth's atmosphere is not oxygen. Earth's atmosphere is composed of 78% nitrogen, 21% of oxygen, 0.9% of argon, and 0.1% other gases. Trace amount of carbon dioxide, methane, water vapor, and neon are some of the other gases that make up the remaining 0.1%. The Earth's atmosphere is divided into 5 layers. It is based on their temperature. The first layer is the troposphere. 12 km, the troposphere is thickest at the equator and much thinner at the north and south poles. The majority of the mass of the entire atmosphere is contained in the troposphere, between approximately 75 and 80%. Most of the water vapor in the atmosphere, along with dust and ash particles, are found in that troposphere, explaining why most of Earth's clouds are located in this layer. Temperatures in the troposphere decrease with altitude. The next layer is the stratosphere. 12 to 50 km, the stratosphere is the next layer up from the Earth's surface. It reaches from the top of the troposphere, which is called the tropopause, to an altitude of approximately 50 kilometers or 30 miles. Temperatures in the stratosphere increase with altitude. A high concentration of ozone, a molecule composed of 3 atoms of oxygen, makes up the ozone layer of the stratosphere. This ozone absorbs some of the incoming solar radiation, shielding life on Earth from potentially harmful ultraviolet light, and is responsible for the temperature increase in an altitude. The next layer is the mesosphere. 50 to 80 km, the very scarce water vapor present at the top of the mesosphere forms noctilucent clouds, the highest clouds in Earth's atmosphere, which can be seen by the naked eye under certain conditions and at certain times of day. Most meteors burn up in this atmospheric layer. Surrounding rockets and rocket-powered aircraft can reach the mesosphere. The atmosphere is thin here, but still thick enough so that meteors will burn up as they pass through the mesosphere, creating what we see as shooting stars. The upper boundary of the mesosphere is called mesopause. The next layer is the thermosphere. 80 to 700 km. In this layer, temperatures increase with altitude due to the very low density of molecules found here. It is both cloud and water vapor free. The aurora borealis and aurora australis are sometimes seen here. The International Space Station orbits in the thermosphere. Not much is known about the thermosphere except that temperatures increase with altitude. Solar radiation makes the upper regions of the thermosphere very hot, reaching temperatures as high as 2000 degrees Celsius or 3600 Fahrenheit. The next layer is the exosphere. 700 to 10,000 km, the highest layer of Earth's atmosphere, and, at its top, merges with the solar wind. Molecules found here are of extremely low density, so this layer doesn't behave like a gas, and particles here escape into space. While there is no weather at all in the exosphere, the aurora borealis and aurora australis are sometimes seen in its lowest part. Most Earth satellites orbit in the exosphere, the uppermost layer that blends with what is considered to be outer space is the exosphere. The pull of Earth's gravity is so small here that molecules of gas escape into outer space. So, why this atmosphere is important to the Earth? The Earth's atmosphere protects and sustains the planet's inhabitants by providing warmth and absorbing harmful solar rays. In addition to containing the oxygen and carbon dioxide, which living things need to survive, the atmosphere traps the sun's energy and wards off many of the dangers of space. That's all. Thank you for watching.